My name is Jan Rüdiger and I'm today at the Embedded World North America. And I'm representing Elektrobit here with our tools. First of all, I would like to show you what we do for the virtual development. What makes this one special is that we're presenting here a way to develop your software on a target that is not even available yet, by already porting our product, our AutoCore, our AUTOSAR based product, onto a virtual target with a simulator called Synopsys VDK. And that puts us into in the position that we can do already the complete software development from start to end, including testing, by simply using a virtual target.
How accurate can it be compared to the real hardware that comes out later?
So that's a really good question. So that is really accurate, because that is a level 4 simulation, meaning we're simulating the complete chip here within the simulation, which means that the very same files the IP provider is using to later tape out the chip is also used within the simulation. So it's really a chip simulation, a one-to-one simulation. We're not simulating the behavior.
So do you want to develop the software before the hardware comes out, so it's ready when the hardware is ready?
Correct. That is exactly the point of this simulation.
And how common is it in the industry to do it in this way?
It is not yet that common, but there is a huge desire in order to what the automotive industry calls a shift left, to more and more move to these kind of systems.
And is there any AI involved in this?
In this one, not directly. There could be some AI involved in the testing later, but for the development itself here, there is not, no.
So here on the screen, what do we see? Is it describing some of the stuff you do?
It is. So what we are showing here in this demo is what we call the Linux for Safety application. And what we're doing here is we answer the question for how to bring Linux into an automotive system, so into a car, and at the same time making it safe. Yeah? We have a pretty nice, patented and industry first solution to the problem of actually making Linux safe to be used in cars. The way this works is that we put on top of the hardware, we put a hypervisor. In this hypervisor, we put our safety monitor, which can then monitor the different machines that are running on the hardware. And similar to what we saw on the left side, where we simulated the hardware, the interesting part here is, yes, this system can run on a hardware, no problem. We have this ported to different hardware, but what you see here is that this is running in an AWS EC2 instance, so it's running again in a cloud. So if someone wants to start their development using our Linux for Safety application, they simply log into AWS, get their hands on an instance of this cloud, and they can start right away.
And here on the what's called the marketing materials.
Yeah.
What else are you talking about? What are those QR codes showing?
So these QR codes will point you to the different landing pages we have for the different products. So if you really want to start your Linux development in a safety critical environment, all you need to do is you scan this code. It will bring you to the AWS marketplace, which you can then use to start it. And the same is for the different other products we have. So these QR codes guide you to our products and you can start with them.
And what is the virtual IVI on Android?
The virtual IVI, this is what we do not have here, but the virtual IVI follows the same principle, just for in-vehicle infotainment systems or in dashboard systems, where we provide a complete end-to-end solution for our customers to start their virtual development for IVI systems in the cloud without having a hardware in place.
Isn't there a lot of Linux in automotive market already? And are you saying that it's sometimes not secure the way it's done?
No, not secured. Yes, there absolutely is Linux in the car as of today. The problem or the question that could never really been answered so far was how to make it safe. So safe in a way that we can use it for ADAS systems, for example, or to drive a dashboard which has a ASIL B requirement according to the ISO 26262.
So the upcoming self-driving cars, the full self-driving, is going to have a whole bunch of Linux, and it's going to be safe, and it's going to make for a better car?
Yes, yes, and it will be from Elektrobit.
HDMI technology powers the global ecosystem of connected devices, enabling advanced displays that deliver immersive visuals and sound across entertainment, professional, and everyday applications.
As the preferred technology for digital AV connectivity, HDMI technology and the features and benefits it enables
Links billions of products worldwide, from HD TVs, set-top boxes, and laptops to gaming consoles, projectors, and audio-video receivers. It provides the reliable, high-bandwidth connectivity needed for today's ultra-high-definition video, lifelike color accuracy, and immersive sound formats. HDMI technology drives innovation across industries, including digital signage, medical imaging, education, and esports. With unmatched performance, interoperability, and scalability, HDMI technology continues to define how content is created, shared, and enjoyed around the world.